It says the data below. Oh, you guys could read that on your own. Bottom line is we have a table right here to analyze. You will have this on your final, so please pay attention. It is important to follow the instructions on this. It says for you to use, right here it says, use the second and last ordered pair shown. Right here, the second and last. So I need to use this second one right here and this last one right here. I want to use this coordinate and this coordinate to write my line that best fits my prediction equation, okay? And then after that, we're going to be able to use that prediction equation that we come out with to find this missing value. Now keep in mind that these are all inputs and outputs, inputs and outputs, inputs and outputs, right? So what we really have is two coordinates that they want us to use. They specifically tell us to use the second and the last. On the final, they might tell you to use the first and the third, the second and the last. I don't know. Right here, they're telling us to use the second and the last. So let me rewrite those coordinates in coordinate format just so we're a little more comfortable with it. It's 1.4 and 24, and the coordinate 2.4 and 15. Okay, so what could we do with 2 points? We could find the slope using the slope formula. So the slope, of course, is y2 minus y1 over x2 minus x1. So let's plug it in right here. And the x and the y is up here, and the x and the y are over here. This is your first point. This is your second point. So y2 is really 15. y1 is really 24. x2 is 2.4. x1 is 1.4. Okay? So hopefully we have calculators. That way we don't make mistakes on this simple subtraction. 15 take away 24 is negative 9. And 2.4 take away 1.4 is 1. So our slope, our m value, happens to be 1. Okay? 9. Negative 9. Sorry. My bad. Negative 9. So we have our slope. We have some points. I would go with point slope form. Do you guys remember point slope form? Point slope form is y minus y1 equals m parentheses x minus x1. So we already have the slope. That's negative 9. I'm just going to plug it in right here. Negative 9. X minus x1. Well, where are we going to get x1 from? It's over here. x1 is 1.4. And close parentheses. And then you have y minus y1. y1 is 24. And of course you have the equal sign between the 24 and the negative 9. So that's your point slope form equation. You could use this equation to find your missing values. So this is your line of that best fits, your prediction line. If you wanted to rewrite it in slope-intercept form, you could always distribute that negative 9 into each of those terms and then move the 24 over. So I guess it ultimately depends on your multiple choice answer, whether it's in point slope form like this. I don't remember whether it's in point slope form or slope-intercept. So let's say you didn't find this. It might be in slope-intercept. So we might as well do this work and distribute negative 9 times x. And that'll be negative 9x. Actually, let me rewrite this with more space. Put that to the side up here. So if I distribute negative 9 times x, that's negative 9x. If I distribute negative 9 times negative 1.4, that's going to be positive 12.6. And we still have the equal sign and the y minus 24. So you'd have to add 24 to both sides, plus 24 here, cancel it out, plus 24 over here. And that would give you y equals negative 9x plus 36.6. So it all depends if they're giving it to you in y equals mx plus b form, the answer, or point slope form, which would be this: y minus y1 equals m parentheses x minus x1. Guys got it? Now we still need to find that missing value, and you could use either equation. You could use either equation to find this missing value of 2 right here. So if you want to find the missing value of 2, the output when the input is, if you're trying to find this missing output for the input of 2, you could either plug it in here or over here, whichever one you want, depends on which form they give you on your multiple choice answers. I want to go with this guy over here. So that'll be y equals -9 times 2 plus 36.6. Okay? So that's going to be y equals -18 plus 36.6. And with the calculator, -18 plus 36. So y equals -18.6. So your answers for this complicated question is your equation. It might be in point-slope form, it might be in slope-intercept form, but they also ask for that missing value, which is -18.6. Positive 18.6. Why am I saying -18.6? Positive 18.6. Down here, a -18 plus 36.6, that's a positive 18.6. I apologize. Bless you. So positive 18.6 is your final answer. Moving on. I know you guys love this next part, domain and range, right? So domain and range. Domain are your x values, left and right. Range are your y values, up and down. So is there any part of this graph, this piecewise function, it's 2 pieces, is there any part of these pieces of this graph that has an x value of 5? No. So x cannot be 5. Could x be 4? No. How about after? I'm just kidding. How about x being 3? Yes, right? 3, it's there. How about 2? Yes. 1, yes. So do you guys see what I'm talking about with regards to domain? Domain are your x values, and you want to state where your x's are at. Now obviously it's between here and here, right? So you can't really set it up the way I just did down here, x is greater than or x is less than. It's actually an area between here and here. So this is my area between here and here. So it's going to be a compound inequality for the domain. So scratch that. Let me write it over. Domain, you're going to put x in the middle. You're going to put your smaller number on the left side, the -4. The bigger number on the right side, the +3. Now since you put the smaller on the left and the bigger on the right, it's going to be both less than symbols always, because it's always going to be opening up to the right because the numbers on the right are greater. And they are less than or equal to. Thank you, Jonathan. Because this is a solid dot at -4, solid dot, so it's an or equal to. Solid dot, it's an or equal to. If this would have been an open dot, this would have been just a less than. If this would have been an open dot, just a less than. Good call, Jonathan. So do we understand domain on number 12? Okay, how about the range? Same concept, but instead of x's, we're talking about y's. And we are going to put a y in the middle. Now it's just a question of, do we have a y value at 5? No. Y value at 4? Y value at 3? 2? Yes. 1? Yes. 0? Yes. All these values, yes. But then this is the last spot that you have a y value with the graph on it. So this is y value of -3. So it's from here at -3 all the way up here to +2. So how are we going to describe that as a compound inequality with y in the middle? What number belongs on the left? -3. What number belongs on the right? 2. How about the symbols? Both less than. And since they are solid dots, or equal to on those less thans. Cool. That's it. How about this next one right here? What's your domain? Let's talk about x's. Domain, x's. All right, here are my x's. Does this line touch the x value of 5? Negative 5, negative 4, negative 3. It touches all these. And so what could we say about the domain values? And all real numbers. This goes that way forever. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1,000, a billion, keeps going. This one goes to the negative forever. So we could say that your domain is all real numbers. How about the range? This range is a little interesting. The range, is it y is greater than a certain value? Y is less than a certain value? Y is between certain values? Ladies and gentlemen, let me ask you this. Is any part of this graph at y equals 3? Huh? How about at 2.5? How about at 2? Yes. How about at 1.9? Is it at 1.9? No, it's not, right? It's only where? Only at y equals 2. It's not at 1. It's not at 0. It's not at... Is it at y equals negative 1? Yes, it is also. But it's not at y equals negative 2. So there's only 2 y values. Specifically 2 y values that this range has. And what is that? Y equals 2 and y equals negative 1. Those are your range values. And actually, you could just say 2 and negative 1. Those are your range values. Specifically 2 numbers. Moving on to this next one. What's the domain here? What could he say about x? All real numbers. It goes to the left forever. Even though it's going down, it still continues to go to the left, all the way down to the left. And how about to the right? Does it go to the right forever? Even though it's going up, it surely does go to the right forever. So the domain, once again, is all real numbers. How about the range? Y is also all real numbers. Because this thing does go down forever and it does go up forever. So both domain and range are all real numbers. I hope this helps.